Hi, I'm Alex Bishop, and welcome to my Grade 12 Advanced Functions CCT. Today we'll do everything from factoring to synthetic division to graphing as we solve a question based out of the Grade 12 course curriculum. The question of focus is from page 148 of the textbook, question number 14, and is as follows. The function f of x is equal to kx cubed minus 8x squared minus x plus 3k plus 1 has a 0 when x equals 2. Determine the value of k. Graph f of x and determine all the zeros. Then rewrite f of x in factored form. Now to reinterpret the question, we must highlight the important parts. The important parts include the equation and the given zero as they help us start off the question. This leads into the table of contents, otherwise known as my plan in solving the question. First, we will solve for k using a method learned in previous math classes before advanced functions. After that, we will rewrite the equation with the solved variable. Next, we must use synthetic division to simplify the equation, a method learned in Unit 2 of advanced functions. The fourth thing we must do is factor the equation after it's been divided, a method also learned in Unit 2. Next, we will find the properties of the graph from the equation learned in Unit 0. After that, we will find the values to graph the polynomial and then actually graph it, a method also learned in Unit 2, Lesson 3. The first step to solving this problem is to solve for the first and most important unknown variable of k. As we've previously discovered, the x-intercept, otherwise known as a 0, is at x equals 2 or the coordinate 2, 0. Using this coordinate, we plug in 2 for the variable of x and 0 for the variable of y, or in this case f of x. After doing this, we are left with just one variable in the equation, which is k. From here, we must solve for k by expanding the equation where applicable, giving us an equation of 0 equals 8k minus 32 minus 2 plus 3k plus 1. Next, we must collect like terms, leaving us with 0 equals 11k minus 33. Once the term is a binomial, we can move the negative 33 to the left side of the equation by adding 33 to both sides, leaving us with an equation of 33 equals 11k. Next, we must isolate for the variable of k. To do this, we have to divide both sides by 11, giving us 3 equals k and the value of our variable. The reason we solved for k first was because, from what we've learned up to this point, you can't graph an equation that has two variables. Knowing this fact, in step 2 we need to plug in 3 for the variable k back into the original equation to find our final equation. Once 3 has been replaced in all variables of k, we have to expand the equation, which gives us f of x is equal to 3x cubed minus 8x squared minus x plus 10. The equation is now one step closer to having the ability to be graphed. To allow the equation to be graphed, we must undergo the process of synthetic division. Synthetic division is a method learned in Lesson 6a of Unit 2, which is polynomial functions, equalities, and inequalities. It allows the equation to drop an x variable from every term. For example, x cubed will turn into x squared. Before anything else, we must find a factor of the equation f of x is equal to 3x cubed minus 8x squared minus x plus 10 to act as a divisor. The easiest way to do this is to do trial and error with positive and negative factors of the constant term, in this case 10. The answer that proves it is a factor will give an answer of 0. The first number to try would be 1, which has the equation equaling 4. Next is negative 1, which is a factor as by plugging in negative 1 for every x makes the equation equal 0. This means x plus 1 is a factor and we can move on to synthetic division. After synthetic division, the equation now stands as follows. F of x is equal to bracket x plus 1 close bracket 3x squared minus 11x plus 10 close bracket. To make the graphing easier on ourselves, we can put the equation into factored form now rather than later. Factoring is a method learned in grade 11 functions. In this case, we'll be doing complex factoring, as there is a coefficient greater than 1 on the first term. By doing this, it allows us to find the other zeros, the degree, and the end behaviors later with ease. The x plus 1 has already been factored, so we can move right into factoring the other term. By using the crisscross method, taking two multiples from each term, the first and the third terms to equal the second term, in this case 1 and 3 as multiples of 3, and 2 and 5 as multiples of 10, we can determine that the fully factored equation stands as f of x equals bracket x plus 1 close bracket, bracket x minus 2 close bracket, bracket 3x minus 5 close bracket. The equation is now in factored form and becomes easier to graph. The properties of the graph must be found next in order to draw the actual graph. The different properties of the graph we are solving for is a method learned in Unit 0 when discovering the properties of the 10 base functions. First, we know from factoring the equation and taking the roots that the zeros of the graph are -1, 2, and 1.67, or at the coordinates bracket -1, 0 close bracket, bracket 2, 0 close bracket, and bracket 1.67, 0 close bracket. Another thing we know is that the equation has a degree of 3. With an odd-numbered degree, we know the graph has opposite end behaviors, meaning the graph either comes from the bottom and leaves us at the top, or comes at the top and leaves at the bottom. To figure out which end the graph comes from, we take the sign of the leading coefficient, which in this case is positive, along with the fact that the cubic function has a positive coefficient and odd degree, starts at the bottom and ends at the top. We now know that the end behaviors are as follows. As x goes to infinity, y goes to negative infinity, and as x goes to negative infinity, y goes to positive infinity. Another property we know is that both the range and the domain are x and y are equal to any real number. These will help us when it comes to creating the graph. To verify these properties make sense, we need to make a table of values to plot coordinates on the graph. First, the graph needs a point to shoot for after the last zero. This is where we plug in 3 for x and get 16 for y. Second, the point where x equals 2 is already a 0, meaning y equals 0. Next, there needs to be a point in between the zeros of 2 and 1.67. By averaging the two out, we can plug in 1.84 for x and get negative 0.24 for y. The next point is the second zero at 1.67, where y again equals 0. The fifth point is between the zeros of 1.67 and negative 1, averaging out to an x value of 0.34 and a y value of 8.85. The next point is the y-intercept, where x is set to 0, and after solving y is equal to 10. The seventh point is the 0 at x equals negative 1, which clearly has a y value of 0. Finally, the last point needed is one left of the last 0, which is a number such as negative 1.5. After this number is plugged in, the y value found is 16.63. The seventh and final step is to plot all the points onto the graph and graph the equation. The points needed are bracket negative 1.5, comma negative 16.63, close bracket, bracket negative 1, 0, bracket, bracket 0, 10, bracket, bracket 0.34, comma 8.85, close bracket, bracket 1.67, comma 0, close bracket, bracket 1.84, comma negative 0.24, close bracket, bracket 2, 0, close bracket, and bracket 3, 16, close bracket. Once all the points are plotted, we can draw a line through them and connect them and complete the graph. A career where this type of problem would be solved would be physical and social scientists, including archaeologists, astronomers, meteorologists, chemists, and physicists. They need to use polynomials in their jobs to find key scientific formulas, including gravity equations, which feature polynomial expressions. These algebraic equations help scientists to measure relationships between the characteristics such as force, mass, and acceleration. Astronomers use polynomials to help in finding new stars and planets and calculating their distance from Earth, their temperatures, and other features. This concludes the solving of the problem, as we have successfully found the value of k, determined all the zeros, rewrote the equation in factored form, and graphed the equation. Thank you for your time.